Hello guys, welcome to today's video. In this video we are going to talk about the continuity of function, the continuity of a function. A function is said to be continuous at a point A if and only if three conditions are satisfied. For a function to be a continuous function, three conditions need to be satisfied. The first condition is f of A is defined. The second condition, the limits of f of x as x approaches A must exist. The third is the limits of f of x equal to f of A as x approaches A. These are the three conditions needed for a function to be a continuous function. If these three conditions are not met, then that function is said to be a discontinuous function. Now we're going to take some examples on the continuity of a function. The first example is given a function f of x equal to 3x plus 6 at x equal to 2. Now that's the first example, so we're going to check if this function is continuous. So we're going to follow the three methods. The first method says f of A is defined, and remember it's from definition. I said A is a point, so A was given at this function, A is 2. So to check if f of A is defined, so the first condition, check if f of A is defined. So in place of A we put 2, so f of 2 is equal to, wherever we see x we place our 2, so we're going to have 3 into 2 plus 6. 3 times 2 is going to give us 6. 6 plus 6, we're going to have 12. So we have proved the first condition. The second condition, the limits at x are A is 2 of this function. So wherever we see x is impute 2, so we're going to have 3 into 2 plus 6. 3 times 2 we have 6 plus 6, which is going to give us 12. So in this function, we've defined the first one. We've checked that the first one is defined, the second one exists. Now we're going to go into the third one. Now, to check if the third one was going to work, so we said the limit of f of x is equal to f of A. So for the third condition, the limit of f of x is 12, which is equal to the limit of f of A is 12. So therefore, this function is a continuous function. So I'm going to go into the second example. Which is given a function f of x, which is equal to x squared minus 9 over x minus 3 at a point x is equal to 3. Now looking at this function, the numerator is a perfect square. Since it's a perfect square, x squared minus 9 can be written as, x minus 3 and x plus 3. Since 9 is a perfect square, then the square root of 9 is 3. So therefore, when we expand this, we're going to have this. So we can rewrite our question to be x minus 3, x plus 3, all over x minus 3. So this and this is going to go out. So we're going to have f of x, which is equal to x plus 3. Now this is our function. So to check if these three conditions are going to be satisfied, we are going to check if f of A exists, which is f of 3, because our A is given to be 3. So the first one is checking if f of 3 exists. So putting it into the equation, x plus 3, I'm going to have, wherever we see x, we place 3, so 3 plus 3, which is going to give us 6. Right, now checking for the limits of x as x approaches 3 of x plus 3. Wherever we see x, we put 3, says 3 plus 3, which is going to give us 6. So therefore, the limit, which is 6, is equal to f of a, which is 6. So therefore, this function is a continuous function. So we're going to take the last example. So which is given a function. We have two functions in this question. For x less than 1, we have 3 here. For x equal to 1, then we have x plus 2 for x greater than 1. Since x is less than 1 and x is greater than 1, the function f of x is defined by a straight line. Therefore, the function will be continuous for all x not equal to 1. So therefore, in this solution, I'm going to start like this. For x equal to 1, I'm going to say for x equal to 1, f of 1 was given to be 3, which is this. It was given to be 3, which is for this. So, and we have we have two functions rather. We have the function on the right hand side and the function of the left hand side. So for we to know which of the function is in the left hand side and in the right hand side, the one carrying a lesser than sign is for the left hand side, while the one carrying the greater than sign is for the right hand side. So we're going to solve for the left hand side. So solving for the left hand side, so I'm going to take for the limits. We already told that if we're already given that for f of 1, we're going to have 3 for the both equation. So we're going to go to the second condition, which is the limit. So we're going to take the limits for the left hand side and for the right hand side. So solving the limits for the left hand side, we're going to have the limits as x approaches 1 of 5 minus 2x. So wherever we see x, we put 1. So I'm going to have 5 minus 2 into 1. 2 times 1 is 2. So we're going to have 5 minus 2, which is equal to 3. So I'm going to go into the right hand side. For the right hand, so I'm going to take the limits as x approaches 1 of x plus 2. So wherever we see x, we put 1. So we're going to have 1 plus 2, which is going to give us 3. So therefore, the limits of both the right hand side and the left hand side gave us 3. And the first condition, which is f of 1, for these two functions gave us 3, which was already given to us. So therefore, we can say the limits of f(x) at the right hand side is equal to the limits of f of x